Welcome to this ARSET training entitled NASA Earth Observations for Energy Management. My name is Natasha Sadoff. My team and I are very excited to be providing this introductory training as it's the first time ARSET has focused on energy. This training will take place over 4 parts throughout June. Today we'll be focusing on an introduction to energy management and relevant data sets and tools broadly. Next week, we'll talk about climate resilience and some specific real-world applications using NASA data. Part 3 will focus on resources for renewable energy and building energy efficiency. Finally, Part 4 will focus on using the prediction of worldwide energy resources or power tool. We'll share this information with you via 4 90-minute webinars. We'll have a presentation or a demonstration, followed by a discussion and time for question and answer. We ask you to complete a knowledge check at the end of the series. If you participate in all 4 sessions and complete the knowledge check, you will receive a certificate of completion from ARSET. In order to get the most out of this series, we recommend that you've taken the Fundamentals of Remote Sensing course available through ARSET. This course has 3 main learning objectives. First, the course will summarize priorities and challenges in the energy management sector and how various Earth observations can support decision-making. This is the first course offered by ARSET on energy management, so we want to set the stage and establish an understanding of the context in which these data may be applied. Second, the course will expose participants to online tools that can be used for acquiring data from satellite missions, visualizing data, or conducting analyses. We'll provide an introduction to some of the downloadable data sets and dashboards or mapping tools that NASA offers, which can provide insights into variables relevant for energy management. Finally, participants will gain familiarity with how to use NASA data for various example case studies in renewable energy, energy efficiency, and climate resilience. You'll hear from various speakers during this course. Again, my name is Natasha Sadoff. I'm a senior research scientist at Battelle Memorial Institute. I'm a geographer who specializes in capacity development, science translation, and stakeholder or end user engagement in environmental management areas such as energy and air quality. In addition to me, in part 1, you'll also hear from Amy Libran, a lead social scientist at Battelle with a decade of experience matching Earth observation data with end users for enhancing decision-making. She's worked in climate vulnerability, vector-borne disease, and energy management. In part 2, you'll also hear from Meredith Fritz, a social scientist at Battelle with expertise in information dissemination and outreach in environmental and health areas. She focuses on global health, human dimensions of environmental change, and how to effectively engage stakeholders and end users in this kind of research. In parts 3 and 4, you'll hear from Dr. Paul Stackhouse and Bradley McPherson. Paul is a senior scientist at the NASA Langley Research Center. He leads teams in estimating and understanding the Earth's radiative budget at the top of the atmosphere and the surface from satellite observations and radiative transfer. He also specializes in preparing those and additional data products for use in renewable energy, sustainable building, and agro-climatological applications. Bradley is a geospatial developer supporting the Power Project, which you'll hear about in this series. He leads the development and sustainment of data distribution services and the data processing pipeline to support near real-time data distribution to the public to enable open science. Additionally, Bradley specializes in data science, spatial analysis, and geospatial policy to support public accessibility and usability of Earth observation data. For those of you who may be unfamiliar with the ARSET program, we're part of NASA's capacity building program under Applied Sciences and are designed to empower the global community through remote sensing training. We have a variety of training topics within 4 application areas: air quality, water resources, disasters, and eco-forecasting, which is where the ARSET team resides. Our training levels are on the spectrum from introductory all the way to advanced trainings with guides for remote sensing analysis. This series is on the introductory level. Our trainings are designed for professionals with natural resource management agencies, policymakers, and other environmental decision makers. Now we're ready to start. First, I'm going to set the stage with an introduction of Earth observations for energy management. As I mentioned before, we want to understand the context in which Earth observation data may be applied. Let's start with some background on the energy sector, including the driving forces behind energy demand and sourcing. As many of you know, fossil fuels such as oil, coal, and natural gas make up 80 to 90% of global energy sources, so renewable energy is increasingly becoming a more significant part of the global energy portfolio. Incentives and lower costs are allowing for renewable energy to compete with traditional fossil fuel sources. In the United States, for example, energy sourcing may see dramatic shifts over the coming years. The Biden administration is starting to execute on a platform that includes rejoining the Paris Climate Accord, investing $2 trillion in clean energy, and fully decarbonizing the power sector by 2035 in order to achieve a larger goal of net zero carbon emissions by 2050. However, the coronavirus has also had an impact on energy demand this year. In the US, the Energy Information Administration, or EIA, forecasts that electricity consumption will increase by 2.1% in 2021 after it fell 3.8% in 2020 due to the COVID-19 lockdown. The rest of the world mirrors this, though energy consumption and gross domestic product, or GDP, recovery are still highly uncertain. Nevertheless, demand continues to grow, and overall consumption has doubled between 1990 and 2016, as you can see on the slide. Energy consumption for the industrial sector, which includes refining, mining, manufacturing, agriculture, and construction, accounts for the largest share of energy consumption of any end-use sector. Together, China and the United States represent 40% of global energy consumption. Demand will likely continue to increase due to population growth, expanding access to energy, and greater demand for renewable energy. Energy providers around the world are seeking to meet this need via greater and smarter energy transmission and distribution. Utilities have increased spending on infrastructure improvements to maintain and sustain reliable transmission and service. The current electricity grid in many parts of the world may not be adequate for the necessary energy transmission as demand increases and sources shift to renewable sources. Other types of energy infrastructure, such as underground lines, conductors, poles, fixtures, towers, stations, and other equipment, will also continue to see a need for investment as the energy portfolio evolves. An evolving energy mix is not the only shift or challenge that the energy infrastructure we have is facing. There are several important factors that can affect energy production, distribution, transmission, and consumption. Some vulnerabilities stem from geopolitical uncertainty, such as global financial changes, volatile oil prices, or policy change. COVID-19 has obviously resulted in several projects, such as rural electrification and other improvements, to be put on hold. In fact, parts of sub-Saharan Africa are expecting to see the number of people without electricity rise. Further, cybersecurity threats and environmental threats, such as extreme weather or climate change, can pose serious threats to energy. Climate resilience is one of the most pressing challenges that the energy sector faces today. Energy infrastructure is at risk of damage with interruptions to energy transmission from extreme weather, climate change, and other environmental factors. In fact, the energy sector itself is even a key contributor to climate change via the release of greenhouse gases. In the United States, the number of billion-dollar disasters has been increasing steadily since the 1980s, as you can see on the table here. A shift to resilient and renewable energy can mean a more resilient energy sector, including an emphasis on building efficiency and energy efficiency. However, this necessitates an understanding and quantification of weather and climate disasters. You may recognize this figure from the U.S. National Oceanic and Atmospheric Administration, or NOAA, showing the billion-dollar weather and climate disasters that hit the U.S. in 2020 alone. 2020 set a new annual record of $22 billion events. These events included drought, flooding, freezes, severe storms, tropical cyclones, wildfires, or winter storms. From 1980 to 2020, the cost of $285 billion disasters is $1.875 trillion. All 50 states in the U.S. have had at least $1 billion disaster, with Texas facing the most of any state, 124 since 1980. As energy demand increases, we see a feedback loop of increasing emissions, increasing contributions to climate change, and intensifying extreme events. Utilities and other energy management stakeholders will need to invest in resilience in order to maintain a reliable energy supply. We've talked about the myriad challenges facing energy management. However, challenges in climate resilience, sustainability, and cost risks can be informed by NASA Earth observations. NASA data is underutilized in energy management. However, it can provide valuable insight into energy infrastructure and energy management system and processes. NASA has several satellites that are collecting data on the Earth. You'll hear more detail later in this session and in the rest of our webinars, but NASA data can speak to renewable resource availability, including resources such as wind, solar, and water for hydropower electricity. Earth observations can speak to weather and climate data, such as hydrometeorological variables like precipitation, humidity, and temperature, as well as water cycle-related hydrological parameters and parameters on land cover and vegetation. One of the most important benefits of NASA Earth observations that you'll hear about is the ability to visualize physical, climate, and hydrometeorological parameters to inform energy management efforts or decision-making. In the images on this slide, you can see how NASA products were used in a model to calculate the impact of aerosols and clouds on surface radiation by examining the amount of solar energy on Earth's surface. And you can see the power of a good visualization. Before we get into more detail on how NASA Earth observations can be used in the energy management sector, let's talk in general about several key benefits. First, NASA Earth observations are freely available. They're available through NASA data centers, tools, portals, or Google Earth Engine. In some cases, you may need to create a profile to sign in. However, data are always completely free and accessible. Because Earth observations are often regional or global in spatial resolution, they can be used to fill gaps in data-poor locations or in places where ground-based data sources are limited. Earth observations, therefore, can democratize access to data, especially in areas where there isn't as much available ground-based data. Earth observations can be used to enhance, evaluate, or improve other sources of data or models. There are hundreds of data products, so the next few vary depending on the product. However, Earth observations can offer a short repeat time and broad geographic coverage. There are often long historical data records, sometimes as long as decades. Data are also available in a variety of formats and can be imported as CSV or other file types for analysis, visualization, and statistical use using tools like ArcGIS, Python, R, and other tools. We want to acknowledge that NASA Earth observations don't meet every need. There are a few key limitations of using satellite data for energy management. Again, this is product dependent, but one of the most significant challenges with Earth observation data is coarse spatial resolution. While some instruments produce data with the resolution of a baseball field, other instruments are measuring with regional resolution. Similarly, geographic coverage can be limited to certain regions. In certain parts of the world, cloud cover with optical sensors can block data, limiting data availability and coverage. Latency, or the time it takes for the data to be retrieved and made available to the user, can range from an hour to several days. Therefore, NASA Earth observations are not always appropriate for real-time needs. As always, it's up to the user to ensure that the data products are fit for purpose. Uncertainty and other metadata features should be understood to ensure appropriate interpretation. The appropriate application of data always depends on the user. Let's do a quick poll. We want to hear from you. We have participants from all over the world and from all different types of sectors, and we want to get to know you a little better. We're interested in knowing how familiar you are with NASA data and energy management. And then after the poll, I'll pass to my colleague, Amy Libran, so that we can get into more detail on the kinds of data sets and tools available.
Okay, we're excited to hear what you all think here. So the first poll question is, how familiar are you with the various data sets available from NASA that relate to energy management? So please select one of the three answers: very familiar, somewhat familiar, or not at all familiar. Okay, so this is a pretty good mix. We know this is an introductory course, so it'll be a little bit of a high-level overview of a lot of things. So it's good that most of you are not too familiar, somewhat familiar with 46%. So we're excited. This hopefully will be very useful to most of you. And if you're very familiar, then hopefully this is just thinking of all of these data sets in a new way, thinking about them from the perspective of energy management. So this is great. Okay, let's go to the next poll question. So our next poll question: have you previously used NASA Earth observations in your energy management work? So you can please select yes or no. And we know that there's a lot of Earth observation data from around the world that's available, but we specifically want to know if you've used NASA Earth observation data. Okay, let's see what the results are. Okay, again, so happy to see, not happy that you haven't used NASA Earth observations, but for the purpose of this training, happy to see that most of you, the vast majority of you, have not used Earth observations from NASA in your energy management work. So we're excited that we'll talk about a lot of different ways that you can consider using this data and all this information in your work. So, and for the 14% of you who have, we'd love to even, put some comments in and hear how you have. We'll also have a survey at the end of the series, and we'd love to hear more from you at that point too, and what you've done to date with Earth observations in your energy management work. Okay, great. Let's go to our last poll question. Okay, so if you have not previously used NASA Earth observations in your energy management work, why? So please select one. Don't know what data are available, don't know where to find data, data are not applicable, or other. All right, let's see what the responses are. Okay, kind of a mix here, but 44% don't know what data are available. So that's great, because we will talk about that. I think that's the most important objective of this series, is to talk about all of the different data sets that are available. So 22% don't know where to find data. We'll also talk about that. 4% say data are not applicable. Well, for those 4%, hopefully you might learn some new things about other data sets that maybe you're not familiar with that could be applicable. And for the 31% who said other, hopefully in the knowledge check or in the survey or even in the comments, we'd love to hear what other barriers you've experienced with why you haven't previously used NASA Earth observations. But we'll get into where you can find the data and what data you can find starting right now. So we'll keep going with the presentation.
Okay, now for the next portion of this webinar, I will introduce you to the many NASA resources that are easy to access and visualize for various energy management applications. For some background, Battelle received a grant funded by NASA Applied Sciences to increase the awareness, understanding, and use of NASA data for energy management among electricity utility end users. We used a capacity building approach to identify means of improving the ability of electric utilities to use Earth observations, which involved information gathering to identify utility priorities, needs, and gaps, as well as interviews with electric utilities across the U.S. to prioritize the most relevant NASA data resources for needs across the sector. To compile these valuable resources, we developed a story map, which I will show in a moment, that provides practical, actionable information about NASA Earth observations for electric utility applications. While our project was designed to address electric utilities as a specific set of users, the story map is relevant to a wider array of potential users who are working in energy management applications, including researchers, the private sector, and those working in policy or governance at a city or regional level. The information in the story map may be applied to many use cases, including but not limited to infrastructure management, resilience planning, management of renewable energy resources, and assessment after a disaster or extreme weather. The content of the story map was curated based on the feedback from interviews with electric utilities from across the U.S., industry experts, and experts from the U.S. Department of Energy and NASA, and data gleaned from information gathering. The story map is not intended to be an all-inclusive list of NASA resources for energy management. Instead, story map content is focused on data sources that are easy to access, meaning these sources are free to use and generally easy to find for users not experienced with NASA data portals, and easy to use, meaning that most data presented in the story map are level 3, in which the variables are provided on a gridded map. The purpose of the story map as a tool is to provide an efficient way to identify resources relevant for various applications and help users know where to go to visualize and download NASA data and data products that are most relevant to electricity sector needs. While many visualization tools are referenced in the story map, the tool primarily focuses on Worldview and Giovanni, two free and easy-to-use tools for visualizing NASA Earth observation data. Users can consider any of the NASA data sets in the story map in combination with each other, with proprietary infrastructure and asset data, and with non-NASA Earth observation, like NOAA data, or with ground sensor data from other sources to gain a comprehensive perspective. Listed on this slide are the parameters included in the story map. I'm going to show you the story map now and provide a brief overview of the data sets and products in the story map for each of these parameters. This is the story map homepage, which provides a brief introduction of the tool, how to use it, as well as other information about NASA Earth observations in general. At the top, you can see tabs for case studies, data sets, definitions, and tutorials. In the Data Sets tab, data sets and data products are categorized by parameter. Each of the parameter tabs begins with an overview with a table showing the included data sources and the type of data they contain. We start with energy, infrastructure, and assets, and while most of these sources are not NASA, these are included to provide a starting point for considering infrastructure and asset data as part of the greater perspective when using Earth observation data. Many energy management users have their own data sources that they may combine or augment with NASA Earth observation data. Next, in the Elevation tab, you can see the data sources included here on the overview table. For elevation, we have included 2 digital elevation models and a land and vegetation height product. Elevation affects variables like temperature, precipitation, and air pressure, and can be useful for activities like infrastructure siting, river delineation, and evaluating an area for landslide susceptibility. Choosing between the data sources featured here depends on the characteristics of the area of interest. Some elements to take into consideration when choosing between data sets include vegetation, spatial and temporal resolution, and data availability. To view any one of the sources included in this tab, just click on the name of the source along the side. To show you an example, let's look at the global digital elevation models from ASTER. In each of the specific data source sections, you will find an introduction to that data source, where to find, view, and download data sets, including quick reference to data format, temporal resolution and coverage, and spatial resolution and coverage, and links to validation, theoretical basis, and guidance documents if available. Blue text throughout the story map indicates that the text is linked to an outside source. Click on any blue text to open that link in a new Internet tab. For example, under Datasets, click on ASTER GDEM Products to access the data product. A new Internet tab opens showing the available datasets for ASTER Digital Elevation Model products. From here, you will select your product of interest to access data for download. In this case, clicking on the model opens a new page that provides information about the data product and where to access the data. Here you can see that the ASTER Digital Elevation Model data product is only available through NASA's Earth Data Search. Clicking on this link opens Earth Data, where you can see the ASTER Digital Elevation Model in the collection. To select data to download, simply select your area of interest on the map by using the tools on the right sidebar. Here we will zoom in and I will select an area and then click on the data product to show the matching granules. From here, you can sort the granules you wish to keep and download. So that is one example of how to access data through the story map. You can also see that there is a tutorial available related to digital elevation models. In each of the dataset tabs across the top, you can see, let me start that over, right in tutorials. You can also see that there is a tutorial available related to elevation models. In each of the dataset tabs across the top, you will find tutorials specific to each of those environmental parameters. Here we see an ARSET tutorial about using NASA digital elevation data for river basin delineation that you can play right in the story map. Moving on to evapotranspiration, you can see the data sources included in this tab on the overview table, which are useful in understanding the water cycle. Evapotranspiration is one part of assessing water availability and resource sustainability for hydropower plants, for example. Let's look at the EcoStress evapotranspiration product. Here you can see an example of product output on the right. On the left, similar to the elevation product we looked at, you will see an introduction to the product, information about available data sets, and validation, theoretical basis, and guidance documents. Again, clicking on any blue text will open that source in a new Internet tab. For example, by clicking on EcoStress calibration and validation, a link opens the documentation in a new Internet tab. Going back to the story map, again, when you scroll to the bottom, you'll see a section for tutorials specific to this parameter, evapotranspiration. Next, we have fire and burn products. This tab includes data on fire and hotspot detection, burned areas, smoke, and other resources that can help predict future patterns of fire behavior to assess fire impacts on infrastructure. One great resource I'd like to highlight is FIRMS, the Fire Information Resource Management System, which uses data from MODIS and VIIRS to identify and track fires and thermal anomalies. Global fire data can be viewed in the FIRMS fire map or in WorldView, shown here on the right. Fire data for the US and Canada can be viewed in the FIRMS US-Canada fire map, which is a more feature-rich version of global FIRMS. Let's open the FIRMS fire map. We click on FIRMS fire map and a new Internet tab opens. On the right, you can see the data sources used to create this map. By zooming in and clicking on any of these dots on the map, you can find information about that specific data point. Information includes latitude, longitude, brightness, and so on. You can also, on the right side here, click on gridded fire hotspots, which will show the hotspots throughout the world. The number in the center indicates the fire count in that grid. Going back to the story map, let's obtain data directly from FIRMS. To do so, we click on Global FIRMS Data Download, which opens a new Internet tab with access to data directly from FIRMS that can be downloaded in shapefile, KML, and text file formats. Going back to the story map, we can also view and download data directly from WorldView on the right. Select the date that you wish to view by using the slider at the bottom. You can also select a date on the left side by using the arrows. Zooming in and clicking on a dot will show you information on that data point, similar to the FIRMS fire map that we just looked at. To download data from WorldView for this date, click on the data icon. Then select a data product of interest by scrolling down and selecting which one you're interested in. Whether data granules are available for this date for a particular product will be shown here at the bottom. Here it says none. So we will select another data set. You can also set an area of interest by clicking on Set Area of Interest and adjusting the box. You can find information about each data product by hovering over the I information icon next to a data product and clicking View Collection Details, which then opens a new Internet tab with detailed information about that data product. Back in the story map, once you have selected your desired date, your area of interest, and your data set, you click Download via Earth Data Search in order to access the data files for that product. This will open Earth data and show the available data for the product, date, and area of interest that you selected. Similarly to what we showed before, from here you can sort and select the data that you wish to download. Going back to the story map, clicking on section 6, here we have smoke products from MODIS and VIIRS. These products are land surface reflectance products that provide the ability to view high-resolution imagery of smoke from wildfires, as you can see here on the right in WorldView. You can use WorldView to compare images from different dates by clicking Start Comparison, and then moving the slider at the bottom to select your dates of interest. You can also create an animation of images over a specific time period. To start an animation, click on the video icon and select the dates and parameters that you wish to review. You can save the animation, and you can also add layers and explore imagery many other ways in WorldView. To access WorldView outside of the story map, just click on the blue text that says WorldView, which will open a new Internet tab showing WorldView and the related data products. Back in the story map, a tutorial for how to use WorldView can be found under the Tutorials tab in the header at the top of the story map. Next, we have groundwater and soil moisture, which also includes freeze-thaw and subsurface runoff data that is useful for assessing drought or saturated conditions. These data can be used for assessing fire risk, vegetative stress, and water resource availability, which is also applicable for understanding changes in the water resources for hydropower. Here, you can see soil freeze-thaw data from NASA's Soil Moisture Active Passive Satellite Mission, or SMAP. This mission provides hemispheric estimates of freeze-thaw state at a high temporal resolution. You can visualize this data in WorldView, as seen here on the right. There are several data sources for soil moisture. One is from NASA's disaster program. Here on the right, you can see the disasters mapping portal, which includes quite a bit of information related to disasters, as you can see from the tabs. In the near real-time dashboard, this dashboard brings together 3 soil data sets, along with others like a landslide nowcast, flood layers, evaporative stress index, and sea surface temperature. To obtain data directly from the disasters mapping portal, click on the 3 dots next to your layer of interest, and scroll down and click on Show Item Details. This opens the data access page for that layer in a new Internet tab. Next, we have a few resources for land cover and land use change from Landsat, MODIS, and VEERS, which can be used to monitor environmental and human-derived trends such as urban sprawl or to aid in infrastructure planning. Land cover and land use change can also be used to assess environmental impacts from electric infrastructure development or to assess burned areas after a wildfire. Combined with vegetation indices, these data may also be useful for assessing vegetation management strategies to ensure transmission lines are unaffected by changes in growth trends. This is the MODIS, Terra, and Aqua combined land cover product. Here you can see it is fairly high resolution. compared with some of the other data sets shown. For this particular product, land cover type is organized into 17 classes, including 11 natural vegetation classes, 3 human-altered classes, and 3 non-vegetated classes. The MODIS and VEERS land cover type products are updated annually. We've also included Landsat. Landsat provides moderate spatial resolution imagery in a 16-day temporal cycle. This offers the ability to view more rapidly changing conditions, for example, for estimating hydropower's land use impacts over time. Scrolling to the bottom, similar to the other data product tabs we've seen, we see the Tutorials tab, where there are tutorials specific to land cover classification data that you can view here directly in the StoryMap. Next, we have land surface models and reanalysis models, which provide data for a wide variety of parameters, as you can see in this table. These models were developed using a systematic approach for producing data sets to assess weather and climate changes over time. Many of these layers can be visualized in the Giovanni visualization tool. Giovanni is another free visualization tool where you can also download data. Let's look at data from the Global Land Data Assimilation System, or GLDAS. This system takes satellite and ground-based observational products and applies advanced land surface modeling and data assimilation techniques to generate optimal fields of land surface states and fluxes. Clicking on the blue text that says Giovanni opens a new Internet tab with available data layers for download and visualization. To gain full access to Giovanni features, we recommend signing up for a free account. However, an account is not required to access most data sets or create visualization plots. From here, you can select, sort, and search for data. To download data, simply click on the name of the data set, which is the name that is in parentheses. And a new Internet tab will open with information about that data set, including where to access the data for download. Going back to Giovanni, plotting data in Giovanni is simple. Click the checkboxes for the data sets that you wish to plot, then select the map type, the date range, and the area of interest. Then at the bottom, click Plot Data, and the data will begin processing, which may take a few moments. You can see that the GLDAS data has coarse spatial resolution. However, this model provides a temporally consistent series of data from 1948 through 2014 for the entire world, which is very useful for assessing historical trends. Going back to the StoryMap, a tutorial on how to use Giovanni is included in the Tutorials tab of the StoryMap in the header. Next, we have landslide products. Landslide products are useful in helping to anticipate, predict, and observe landslides, which are a significant risk to energy infrastructure such as power lines or hydroelectric dams. We'll talk more about landslides in session 2 of this webinar series. One example of the products included in this tab is the NASA Landslide Viewer, which uses satellite data and citizen science data to model and inventory landslides around the world. Here we can see data from the landslide catalog, which includes data from past landslides. Again, by clicking on a dot, we'll bring up information about that landslide. You can also add other layers by clicking on the layer icon. One example is landslide susceptibility. To access the data layer, click on the 3 dots next to the layer, scroll down and click on Show Item Details, which opens a new Internet tab with the data information and access options. Back in the story map, next we have nighttime lights. This tab is a little different from the rest in that here we only include one data product, NASA's Black Marble, which is why there is no overview table for this parameter. The Black Marble product was developed with VIIRS data and provides the ability to observe nighttime lights, which is useful for assessment of power loss after an extreme weather event, monitoring changes in energy infrastructure, tracking wildfires and gas flares, and as a proxy for economic activity. We'll cover a real-world example using nighttime lights in session 2 of this webinar series. Next, we have precipitation. Precipitation is an important data set for energy management. Precipitation rate, which is an indicator of rainfall intensity, is useful in evaluating the susceptibility of an area to landslides or flooding, which may impact transmission lines or other utility infrastructure. Historical analysis of precipitation to identify trends is effective for assessing water resource availability for hydropower plants and for prioritizing infrastructure for storm hardening. Note that the first data source is not from NASA, but is from NOAA, the U.S. National Weather Service. While NASA does provide precipitation data from sources such as the Global Precipitation Measurement Mission, ARSET, AQUA, and assimilation and reanalysis models, end-user engagement with utilities revealed that NOAA was the primary source for forecasting data in the U.S., and so we felt it was important to include here. NASA precipitation data may be useful in historical analysis or to supplement NOAA or ground-based data. NASA precipitation data is also useful for providing measurements in regions where the data gaps or where there are data gaps or where ground-based data is scarce. For example, we see here the integrated multi-satellite retrievals for global precipitation measurement, also called eMERGE. This algorithm combines information from the GPM satellite constellation to estimate precipitation over the majority of the Earth's surface. This algorithm is particularly valuable over areas that lack precipitation measuring instruments on the ground. Data for GPM eMERGE is available going back to the year 2000. Next, we have sea level change, which is important for coastal infrastructure, such as power plants and electric infrastructure that is within coastal areas, as these areas will become increasingly vulnerable to sea level rise, flooding, erosion, and storm-related hazards if the climate continues to warm. This tab is a little different from the others because many data inputs are required to understand sea level change, such as sea surface height anomalies, as seen here in Worldview on the right, ocean topography, sea surface temperature, geopotential, ocean salinity, and others. So here we show resources for accessing data sets and analytical tools to aid in the assessment and understanding of sea level change as a whole. Clicking on the first resource, NASA's Sea Level Change Pathfinder, opens a new Internet tab. Here we find a multitude of information about the various measurements that are used to assess and understand sea level change, including access to specific data sets. Going back to the story map, next we have snow products. Snow products include snow cover, snow water equivalent, snow mass, and other related products, which are useful in estimating the potential for water resources for hydropower, the potential for flooding, and change detection to identify trends in the hydrologic cycle. Here is the snow mass product from SMAP. SMAP snow mass estimates are based on a snow model component of the NASA Catchment Land Surface Model. This data can be visualized in and downloaded from Worldview as seen here on the right. Much of the data included in the Snow tab are products developed and distributed by the National Snow and Ice Data Center, which provides global data products for snow cover, snow water equivalent, and near real-time snow and ice extent. Shown here are the snow cover products from MODIS and VEERS. Next is solar radiation. This data is critical for siting and managing solar installations. Also, radiation impacts snowmelt and other environmental variables and is often used as an input in hydrological modeling. Later in this webinar series, we will be providing an in-depth overview of the NASA Prediction of Worldwide Energy Resource Project, or POWER, which was initiated to improve upon the current renewable energy data set and to create new data sets from new satellite systems. NASA POWER also provides solar and meteorological data sets to support renewable energy, building energy efficiency, and agricultural needs. We will discuss how to access and use POWER data in Part 3 of this webinar series. Several of the data sets used by the POWER project are included in this tab, including the GWEX Surface Radiation Budget series and data from MERA-2 reanalysis model. Next, we have surface water and flooding, which includes surface reflectance products, surface water extent, runoff, water height, and several flood products. This data is useful for evaluating trends in surface water height, river migration, and to detect and assess floods and storm surge, as well as for water resource availability for hydropower management. Clicking on Section 8, we will show the NASA Disasters Program Flood Dashboard, which brings together multiple NASA soil, moisture, and flood products with products from the U.S. National Weather Service and the U.S. Geological Service to give us a more complete picture of potential flooding in the United States. Zooming in and clicking on any dot will pull up data about that data point. For global data, a good resource is the surface reflectance products from MODIS and VEERS, which will be shown here in Worldview on the right. These products provide an estimate of the surface spectral reflectance as it would be measured at ground level. These data sets are designed to distinguish between flooded and burned areas and bare soil, and is an effective tool for delineating between flooded and non-flooded areas. As we mentioned before, in WorldView, you can start a comparison or create an animation of the data over time to see changes in flood inundation. Next, we have temperature. This includes air temperature and land surface temperature, which are crucial data for a wide array of utility operations, including trend analysis for infrastructure planning or monitoring heat waves for grid management. Reanalysis data sets are created by combining or assimilating climate observation data with model data from a consistent historical period, producing new data sets for climate monitoring and research that are made up of millions of observations. Reanalysis data, such as that from MERA-2, shown here, has been shown as a sufficient proxy to observations in regions where few weather stations exist. Next, we have vegetation indices and height, which includes vegetation indices as well as data on canopy and vegetation height. This data provides the opportunity to remotely monitor vegetation health for transmission line management, as well as changes in vegetation cover that may impact runoff and water availability for hydropower. Here we see vegetation indices from MODIS and VEERS. You can view the MODIS data directly in WorldView here on the right. Normalized difference vegetation index, or NDVI data, is also available from Landsat, which provides moderate resolution data from 1999 to the present. NDVI is used to quantify vegetation greenness and is useful in understanding vegetation density and assessing changes in plant health. NDVI is calculated as a ratio between the red and near infrared values. We've also included two data sets that assess the vertical height of vegetation. For example, shown here is the Global Ecosystem Dynamics Investigation, or GEDI, which produces high-resolution LiDAR measurements of the three-dimensional structures of the Earth. Finally, we have wind. Wind speed and direction data are available from NASA Power and from land surface models and the MERA-2 reanalysis model. NASA Power, which I mentioned earlier and will be covered in part 3 of this webinar series, provides a great deal of useful wind data for renewable energy management and other applications. The data can be accessed directly from the NASA Data Access Viewer. Clicking on that link opens the Power Data Access Viewer in a new tab. From here, you can select from a variety of parameters, including wind. Going back to the story map, going back to the top, you can see we have case studies, data sets, definitions, and tutorials. Under the definitions tab are definitions of many of the terms used throughout the story map. Under tutorials, there are many tutorials for getting started with NASA Earth observation data and related tools. Remember, tutorials specific to a particular data product will be found in the Datasets tab, which are the tabs that we just went through. Tutorials in the Tutorials tab here are broader in scope. For example, ARSET offers many trainings on water resource management products that show how NASA and other Earth observation data can be accessed and used together. Lastly, in the story map includes a handful of case studies that show how data from the StoryMap can be combined for assessing environmental and climate challenges such as drought, wildfire, landslides, and flooding, as well as suggestions for data sets applicable for hydropower resource management and vegetation management. In each of these tabs, a list of data from the StoryMap is linked along with suggestions about how these data can be used together for assessment and decision making. There are many data sets, products, and useful tools. Excuse me. Okay, gotta start that one over. There are many data sets, products, and useful tools included in the StoryMap that we did not review today, so we encourage you to explore the StoryMap in depth to learn on your own how these valuable NASA products can be used to supplement your existing suite of tools. As we've mentioned, there are other data products available for energy management. These include the NOAA Climate Resilience Toolkit and the NOAA StoryMap for electric utilities that is focused on climate information and NOAA data sources, which would be useful in supplementing the NASA data included in the StoryMap. Also, the infrastructure data sources listed here are a few examples of the possible base layers for use alongside the NASA data resources. A user may also wish to include site-specific data to supplement NASA resources and provide a more comprehensive perspective. Now I will pass things back to Natasha to summarize today's webinar.
Thank you so much, Amy. Let's wrap up our session today with a summary of everything that we covered. We started with an overview of the energy sector, including shifting energy consumption and demand, and the importance of infrastructure resilience. We introduced Earth observations as tools that energy management users can access to better understand threats and vulnerabilities to reliable generation. We discussed the benefits and the limitations of Earth observations, which of course are product dependent. And finally, we introduced you to the StoryMap created by Battelle, and we showed you several example variables, where to find data, and how to visualize different data sets. As Amy explained, these data sets can be combined with other Earth observation or ground data to make an analysis even more locally relevant and even more powerful for energy management planning, operations, and decision making. Feel free to take a look at these references when the slides are posted online to learn more about any of the different topics that we covered. We provided you with a lot of information today. We look forward to your participation in part 2 next week, where we'll talk more about how to use all of these different data sets for climate resilience, and we'll go through a few illustrative real-world examples. Parts 3 and 4 will dive in even more detail into how to use NASA Earth observations for renewable energy and energy efficiency. Now we're excited to hear from you. Let's have a discussion and let's go through your questions.
Okay, so we have been collecting all of your questions and we have them all combined into this Google Doc. So feel free to continue to send us questions. We still have about 23 minutes left that we can address your questions and your comments. So feel free to continue posting your questions in the Q&A section. And for now, we'll start to go through the questions that we did receive. So question 1, what kind of data is used for glacial lake outburst floods? And for anybody who isn't aware, these are a type of flash flood occurring when ice or sediment dams collapse between a glacial lake. So landslides, avalanches, earthquakes, and volcanic eruptions often trigger glacial lake outburst floods. So there are images that can be viewed through Landsat, and we've provided a link here. And then there are various data sets useful for assessing glaciers, as well as assessing ice and snow, available through the NASA National Snow and Ice Data Center. And as we've talked about, there's data available on landslides, avalanches, and some of those other parameters that we've talked about in the training today as well. So question 2, for the fire data available from Earth data, in which format can data be downloaded? So fire data are available in a variety of data formats. FIRMS data are available in NetCDF, HDF, EOS, shapefiles, KML files, or CSV files. Burned area data from MODIS and VIIRS are available in HDF EOS format. Burned area images from Landsat are available in GeoTIFF and other formats. And then MODIS and VIIRS smoke data are available in HDF and HDF EOS5 formats. So you probably heard us say that each product is different, and so the formats are different per product. It's all product dependent, but more information is available on the story map and on NASA websites that are linked through the story map. The next question, what format is most data available in? And that relates to the previous question, but again, product and data set specifics is the key, that data formats vary. And so most data are available in common data formats like NetCDFs, HDF files, GeoTIFF files, or shape files. And in the NASA, the story map that we presented today, we include specifically what types of data formats are available for each product and each data set, because we know that's very important depending on the need and application for which you're looking for data. Question 4, are all of the data available for download in Google Earth Engine? If not, is there a list of NASA data available on Google Earth Engine? So not all of the data sets, not all of the data sets presented here are available on Google Earth Engine, but there is a lot of data available, including elevation, precipitation, ice, land cover, leaf area, MODIS burned area, FIRMS data, surface reflectance, land temperature, all of these and more. We've included a link here that you can access for a list and description. Actually, it's a great list that someone put together of all of the data sets that are tagged to NASA. There's also an ARSET course coming up that is how to use Google Earth Engine for land monitoring applications, that's scheduled in June. There's also some series that were offered in the past from ARSET on flood mapping using Google Earth Engine. So there are a lot of resources available on how to use Google Earth Engine for specific applications using NASA data. And I don't know if anybody wanted to add anything on the ARSET courses there or anything else on Google Earth Engine. Feel free to jump in if any other comments are applicable here. Otherwise, I'll keep going. So question 5 is the sea level change data in Pathfinder USA or global in terms of resolution and coverage. So the sea level change Pathfinder includes data sets across many variables, most of which are global, but not all. Again, data availability is dependent on the specific variable. So we included a link here for you to do a little more research depending on what variable you're interested in. Question 6 is data available in shapefile and TIFF formats. And so like I've said, data are available in a lot of different formats, including shapefiles and TIFFs. Many data sets are available in formats compatible with ArcGIS and other software that you may be using. So there's information available on data formats specific to each product or data set. Again, we try to make that easy to access in the story map, and then through all of the different websites that NASA has on the data sets. That's very clear to be able to find those pieces of information depending on what you're doing. The next question, how accurate is data from NASA Power? For precipitation data downloaded, which source is better, Giovanni or NASA Power? So lucky for you, we have two sessions 3 and 4, that are specific to NASA Power. So I encourage you to stick around and call in for those sessions so that you can get a lot more information, including from the experts that have developed and maintain Power. So validation information for the data available through Power is available online. There's a lot of information to go through. It's very clearly outlined. And again, you can hear more directly from Dr. Paul Stackhouse and his colleagues in sessions 3 and 4. I know they'll talk a lot about uncertainty validation because these are key questions for any application. So the Power solar data is available. It's based on satellite observations for which surface insolation values are inferred. The meteorological parameters are based upon MERA-2, the assimilation model. So validation information is listed via meteorological parameters. And like I said, parts 3 and 4 of this training will go over the uses of Power. So we hope that you'll call in then. So will there be new types of data sets for electric utility applications in the future provided by NASA? I think we haven't answered that because I'm not sure if anybody knows. We hope that this is an area that NASA will continue to invest in. We know that this is a huge priority area, especially as it relates to resilience and climate impacts, extreme events, and the effort of the energy industry to become more resilient to all of those potential impacts. So we're not sure exactly if there will be future data sets, but we do know that there are always new satellites that are coming on board, and data will be available, from these new missions in the coming years. So as new data sets are available, NASA always does their best to share that information, and we encourage you to leave comments and in the survey and knowledge check, share your excitement for new data sets for this application area going forward. So moving on to question 9, what spatial resolution is best suited to work with for application in the energy sector? So this is a good and difficult question. This largely depends on the user need, for example, if you're looking at assessing trends over time or if you're responding to an immediate issue. So some examples of how to use NASA Earth observations for the energy sector and how to use specific spatial resolutions will be provided in the remaining sessions of this series. This is also, as we've seen, if you're looking at something that is with a very fine resolution, sometimes NASA data don't meet those needs. If you're looking for regional or historical data or trends over time, then that's where NASA data can be very powerful. So a lot of these questions, the answer is that it's dependent on the product or dependent on the need or depending on the application of what you're doing. What we recommend is that you look at this menu of data sets that we've offered, assess what the resolution is, and then consider if that's appropriate for your specific need or not. Question 10, is it possible to know how to integrate these data into ArcGIS? NASA provides many tutorials on how to get started with GIS. There's some links here. I know there's a lot of resources also. If you even Google or look for forums, there's a lot of resources available on using NASA data with ArcGIS. Question 11, are the data sets available through APIs? Some data sets are available through APIs. In the StoryMap, you can see the last column in the overview table in each data set tab to identify which data sets can be accessed. So that is available in the StoryMap. It looks like question 12, we still need to provide you some information, so we can go back and answer that question for you. Biomass resource assessment, particularly including movement of biomass like charcoal. So we can look up information to provide for you, and you'll find that in the document when we provide this after the session today. Question 13, using Earth observations, is it possible to find the best locations for solar farms in a country? And if a solar farm is not efficient as forecasted, do you think it could be possible to determine what went not as expected? So the short answer, as you can see, Earth observation data can be used for solar siting. And again, this will be covered in parts 3 and 4 when we discuss the power product. Data sets are available on surface reflectance, solar radiation, and others can be used for solar farm siting. So you'll hear about that more in the coming weeks later in June as we discuss power in sessions 3 and 4. Question 14. Regarding groundwater and soil moisture data products, are you aware of any use cases that try to incorporate them in risk analysis for open pit mining dams? That's a good question and very specific. So as noted here, we will look into this and get back to you. We know that a lot of questions relate to specific use cases and wanting to see examples. So we're always looking to see where have this data been used and how can we share lessons learned or experiences back with the community. So we will look for an answer and see if it actually has been used for that specific purpose. Question 15. Thank you to the speakers. It's our pleasure. My question is, how often are these data sets updated? So again, very specific to the product, to the data set, and to the tools. The StoryMap has links to the data sets and where they're stored on external sites. So all of those external sites will contain the information that's available on updates. So those URLs will be up to date so that you can access that information directly from the source of that product. Question 16. Is the Battelle grant exclusive to businesses or research groups in the US, or can the European space subject matter experts access this grant while using NASA Earth observation data to address energy management across various zones? Excuse me. So I believe maybe this question is asking about the StoryMap, and the StoryMap is available to anybody who wants to access it for their purposes. Excuse me. So, so we encourage you to access it. A lot of the data is global in coverage, so it's applicable to Europe or other parts of the world. So if that's your question, the StoryMap is available for use, and we encourage you to use it and let us know what you think and if it's useful to you. Question 17, what kind of data can be used for crop yield productivity? So Landsat can be used to monitor crops, including corn, wheat, soy, and cotton. There's other data available from the USDA, which is the US Department of Agriculture. We will look into this also and find out specifically if we have an answer to this question. Question 18, as each data set has its own method to be assessed, is there any tool within this application which can combine and provide a holistic summary. So yes, no, there's not a tool to combine data sets in the StoryMap. The StoryMap, really what our goal is sharing. If you remember in the poll, the majority of you weren't aware of resources. And so the StoryMap, the biggest goal is to address that barrier of awareness, where to access information, what's available. You're able to download data, download individual data sets and combine them in your own tools if you want to bring them into ArcGIS or bring them into any other software. And so next week we'll talk about examples of how some of these data sets were combined and what this looked like. But it's really up to the user to determine what specific individual data sets are applicable and then download them directly for yourself. So NASA makes all of this data available, but then the analysis is up to the user. Question 19. Is it possible to produce rainfall-induced flooding from data sets? So hypothetically, this should be possible. You might be able to use data sets available in Google Earth Engine to model rainfall-induced flooding. And I believe, yes, I've seen research doing this. Again, it's researchers or individual scientists that are conducting some analysis or forecasts or projections based on what their research need may be. Question 20. Are there any U.S. utilities or industry groups partnering with NASA to find innovative ways for utilities to utilize this data, as many smaller utilities do not have the resources or technology to investigate the use of this data? Yes, this is a big problem in the U.S. and not only in the U.S., it's also around the world that a lot of smaller utilities are just working on their operations and management and may not have the bandwidth to think about new technologies and innovations that could improve their work. So as far as we know, there are no utilities that are partnering directly with NASA. However, of course, our work, the grant that brought about this training, aims to connect utilities with NASA data sets. So there are some larger utilities in the U.S. that have more resources and are doing a lot of innovation in their analysis and forecasts and using NASA data and other data sets, including ground-based data, drone data, private sector data sets with very high resolution, combining all of these data sets together for their purposes. Those data sets and those analyses are not always publicly available because of privacy and just privacy concerns. So it's a little bit difficult whenever working with the private sector, given those privacy concerns. Some of those best practices or some of those case studies are not available to be shared. But it's a good question, and that's one thing that with this training we hope, by making some of those smaller organizations aware of the resources that are available, that can help make some connections so that some of these data sets can be used for whatever purpose is appropriate. Question 21, what kind of data can we download and process for flood analysis and prediction? Is there any limitation for downloading data? Flood data sets, including all of the details about those data, are available in the Surface Water and Flooding tab, and there's a link to where that is in the StoryMap. And of course, the StoryMap will link to the direct sources of where those data come from. There are no access restrictions. As with all NASA data, it's freely available. Limitations about Earth observations are discussed in general on the Home tab. Obviously, as we've been saying, with any data set, the user has to be very careful in understanding resolution, temporal resolution, spatial resolution, the uncertainty, limitations, and any metadata to ensure that the data set is going to be applied in the appropriate way. Question 22. Do you know if the surface water data products are well suited to give rough estimates for water level estimates for reservoir lakes? Yes, there is one product in particular that is suited to evaluate water level, the Inland Water Surface Height, or ISAT-2 tool. Please see the surface water and flooding tab in the StoryMap where you can find some more information on this. The next question, can these data be used for web application development as an API? I believe we answered this question, but if there's anything else we can add to this before we share this Q&A document, then we will. Question 25. Do we have any remote application by which we can see deep into Earth's subsurface? So hyperspectral imagery can be used to see into the Earth's subsurface. So hyperspectral imaging, HSI, is a technique that analyzes a wide spectrum of light instead of just assigning primary colors to each pixel. These data are available through NASA and may be limited, but it's an area with that's growing. So we encourage you to follow this research coming out of NASA. So we'll end on this question 26. What features are unique to NASA datasets that motivate us to use NASA datasets over data available from other satellites, or maybe from data available from other sources? So many NASA satellites, for example, MODIS, have been in orbit for decades and provide a good opportunity to look at historical trends or data over time. NASA Earth observation data is free. Sometimes, as we've talked about, you need to create a registration or credentials to access, but the data are completely free and available to the public. Most data are public, available globally, which may not be the case. Some other organizations have a more limited geographic coverage. NASA satellites provide global or near global coverage with consistent, continuous, large-scale coverage. Satellites often are orbiting continuously and providing consistent measurement over decades. So like Amy mentioned during the training, there are very clear benefits, but also very clear limitations. So again, if you understand what your applications are, if you are looking for historical trends, if you're looking over broad geographic areas, then NASA data can be a wonderful complement to potentially some other data sources that you're using in your research. And I think NASA data for energy work particularly well when combining with ground-based data or other data sources from private sources or other sources of data. So it looks like we are still going through and providing more answers to the last few questions. So please, we will share this document with you so that you can access all of these links. We'll make sure that all of the questions are answered before we share this document with you, so you'll have more information. We'll make this available to you. So I thank you for calling in. I hope that you'll also join us next week, where we'll talk more about some specific case studies on how to combine different data sets together for some example real-world applications. And then, as we said, again, for weeks 3 and 4, where you'll hear more about energy efficiency, renewable energy, building efficiency, and other areas as it relates to the power tool. So thank you so much for staying with us, and we hope to see you next week.